Rational expressions are ratios of two polynomials where the denominator does not equal 0. Let's do a couple examples here. See, 4w minus 12w plus 36 can be factored, as can the denominator. First, let's factor out a common factor of 2. So we're going to get 2 times 2w squared minus 6w plus 18 on the top. And we'll factor out a 2 on the bottom so we can get rid of that. So we'll get what? 2 times the quantity of w cubed. Just fix the w there. W cubed plus 27. And we should notice that at the bottom there we have a sum of cubes. Let's look at how to factor sum of cubes. Remember, sums and differences of cubes have certain rules. If we have a difference of cubes, a cubed minus b cubed, that can be factored into a minus b times the quantity a squared plus ab, plus b squared. And here w cubed plus 27 is the sum of cubes. That can be likewise factored into a plus b times the quantity a squared minus ab plus b squared. And so here we have a and b as w and 3. 3 cubed is 27. So we'll get rid of those 2's there and then factor it out again. Let's take a 2 out of the top term. Since we have 2 as a common factor between 2, 6, and 18, we get 2 times the quantity w squared minus 3w plus 9. And then on the bottom, we'll factor that cube there. Get w plus 3 times the quantity w squared minus 3w plus 9. And notice we have that same factor on the top and bottom, so we'll just eliminate both of those terms. And so our final answer here in the simplified form is 2 over w plus 3. On to the next example. 3x plus 3w plus bx plus bw over x squared minus w squared times the other quantity, 6 minus 2b over 9 minus b squared. First thing we'll do is factor out a 3 from the first and second term on top, and a b from the third and fourth term on top. We get 3 times the quantity x plus w plus b times the quantity x plus w. And then on the bottom we can notice that's a difference of squares, so we'll get x plus w times x minus w. Now we've got x plus w in both terms on top and once on the bottom, so we can eliminate those. All that will multiply again 2 times 3 minus b. Factor out 2 on top, and then notice again we have the difference of squares on the bottom, 3 plus b, 3 minus b. We have common terms, so we can eliminate those. And that equals, we are left with 3 plus b on the top in the first part, over x minus w. And then this all multiplied by 2 over 3 plus b. And so we can cross out those terms since we'll be left with 1 on top, 1 on the bottom. We finally get 2 over x minus w as our simplified expression. You might not notice it as such, but the area of a triangle can be used to calculate a rational expression problem. So area is 1/2 base times height. We have the base is 8x plus 16 yards, and the height is 1 over x plus 2. So we'll take 1/2 of the base, which is 8x plus 16 over 2, and then multiply that by the height, which is 1 over x plus 2. And we get, we'll take an 8 out of the top. We could do this a couple of different ways. We're going to take out some factors anyway. Get 8 times the quantity x plus 2 over 2. That's all times 1 over x plus 2. So since we have x plus 2 on the top and bottom, we can eliminate those, and we're left with 8 over 2, or 4 yards. So we started with a variable and we ended up with a numerical answer. Okay, next up, let's look at a subtraction of rational expressions. So we have a numbers on top. We have numerical numerators and polynomial denominators, which can be factored. Remember our factoring rules. We're looking for numbers that when multiplied equal 3 and when added equal 4. We've got a plus and a plus, so we're going to factor b plus 3, b plus 1. And then again we've got a plus and plus, plus 5b plus 6. And 2 times 3 equals 6 and 2 plus 3 equals 5, so that's a pretty easy one to factor out. So now we have different denominators. We need to find a common denominator. Well, we've got b plus 3 in both of these terms on the bottom. So we're going to multiply the top of the first one times the missing part, which is b plus 2 from the second one, and the top of the second one times the missing part, which is b plus 1 from the first. And we can put all of those on top. Remember, 1 times b plus 1. We don't have to write the 1. And on the bottom we've got b plus 2 times b plus 1 times b plus 3. Let's continue to simplify this just in case we can eliminate some other terms. So we'll distribute the 2. We've got 2b plus 4, and we'll distribute the negative 1. So we've got negative b and negative 1 on top, and the same denominator on the bottom, b plus 2, b plus 1, b plus 3. And then we'll combine like terms on top. We get 2b minus b is equal to b, and plus 4 minus 1 is equal to plus 3. And then again, that's all over b plus 1 times b plus 2 plus b plus 3, and we'll see a common term on both the top and bottom. So we can eliminate that b plus 3, and we're left with only a 1 on top for a final simplified answer of 1 over b plus 1 times b plus 2. Next up, let's look at equalities. We're trying to solve for a variable here. We've got 8 on the top, 6 on the top. We could do this a couple of different ways. First, let's factor these out. Factor out the denominators. We've got 8 over, we know we've got a and a, so we've got plus 2 and minus 3. Oh, plus 3 and minus 2, excuse me. And then in the second part we've got 6 and a difference of squares, so we've got a plus 3, a minus 3. Again, we've got a common term on both sides, but we're not going to have the common denominator yet. Again, we could do this a couple of different ways. Let's take that whole quantity from the right hand and subtract it over to the left side, so we'll get 0 on the right. We got 8 over a minus 2 times a plus 3, and then that's minus 6 over a plus 3 times a minus 3. Now all of that is set equal to 0. So now let's do our subtraction by finding the common denominator. We've got a plus 3 present on both sides, so what we don't have in the first term is a minus 3. We'll multiply 8 by a minus 3. What we don't have in the second term is a minus 2, so we multiply 6 by a minus 2. We get all of that over a plus 3 times a minus 3 times a minus 2. And just to see if we can simplify further, let's expand the top. Again, a couple of different ways we could do this. First, let's expand the top. We get 8a minus 6a is 2a, and then 8 times negative 3 is negative 24. Negative 6 times negative 2 is positive 12, so negative 24 plus 12 is negative 12. All of that over the same denominator equal to 0. And we're going to multiply both sides by the denominator. 0 times anything is 0, so we're left with 2a minus 12 is equal to 0. Bring our variables on one side and our constants on the other, then divide, and we get a is equal to 6. Next up, we're looking at barn painting. Melanie can paint a certain barn by herself in X days. Her helper Melissa can paint the same barn by herself in 2X days. So Melanie can paint the barn twice as fast as Melissa. 1 barn per X days is Melanie's rate. And then Melissa, call her M1, can paint 1 barn, the same barn, in 2X days. So if they're working together, and X is equal to 5, so it would take Melanie 5 days to paint the barn and Melissa 10 days to paint the barn, how much do they accomplish in 1 day? Well, we've got 1 over X, Melanie's rate, plus Melissa's rate is 1/5 plus 1/10, and that's equal to 3/10. 2/10 plus 1/10 is equal to 3/10. So 3 barns in 10 days, or 3/10 of a barn in 1 day. If you don't believe that, 1/5 is equal to 20%, so Melanie can make 20% of the barn in 1 day. Melissa can do 10%, and added them together, they get 30% of the barn in 1 day. Last example, let's look at some fast food waste problems here. So you've got a little bit of a chart over on the left side and the top. What's the ratio of customer waste to food waste? Whoops, 34 is food waste. Customer waste, look in the middle there, down at the bottom. Customer waste, diapers, etc. is 6%. And so we can just say 6% over 34. 6 to 34, we could phrase that a couple of different ways. Let's take out the common factor and we get 3 over 17. So 3%, or pounds or kilograms or whatever, 3% of customers' waste per 17% of food waste. If a typical day at McDonald's generates 67 more pounds of food waste than customer waste per day, then how many pounds of customer waste does it generate? Well, our ratio is 3 over 17. And we'll start with X for customer waste, and then X plus 67 on the bottom for food waste. 67 more pounds of food waste than customer waste. And so we'll cross multiply and divide. We get 17X is equal to 3X plus 67 times 3 is 180 plus 21, or 201. And then we'll subtract our variables to one side, keep our constants on the other, and divide. So we get 14x equals 201, or 201 over 14 is our final answer. In pounds, we could write a decimal, but since we're working with ratios, I suppose I can keep it the same either way. Use the accompanying figure to find the ratio of waste from corrugated shipping boxes to waste from not from corrugated shipping boxes. So corrugated shipping boxes are 34% of total waste. Then 100% minus that 34 is all other waste not from corrugated shipping boxes, or 66%. And so if we have 81 pounds of waste from corrugated shipping boxes, then X is the pounds not from that. Oh, we didn't get the rest of the question there, sorry. So 34, cross multiply and divide, 34 times X is equal to 66 times 81. Take out my calculator here and get the decimal. Got 34X is equal to 5,346 in pounds. And we'll divide by 34 to get X. So 157.24 pounds of waste not from corrugated shipping boxes.